little bit of recap from book 3. And any questions you have as well, we'll go through it. So we'll do the questions first. We'll go through some of the questions and we'll take it from there. And then we'll get a start on book 4, the last book. Okay. Any questions before we start? I'm going to put about 50 questions up on the screen. So plenty of questions for you. Most of you I've covered already. So it's more like a recap, to be honest. But the more practice, the better. That's the main thing. Right.
Excuse me.
Yeah.
Is it bypass valve which control the fuel flow to maintain at constant speed in APU fuel?
Yeah, that's the one. Yeah. The acceleration control, also known as the bypass valve.
Oh, thank you. Yeah.
Yeah. You might find that question coming up very soon. You read my mind. Okay, right. Let's get on. Start with the questions. So something you'll have gone through anyway, but again, it's recap and see them on the screen as well, hopefully. So let's get started. Seems a bit later today. Right. So number 1, when starting a turboprop engine, what position should the propeller blades be in?
It should be in fine position.
Yeah, I mean, it doesn't specify fixed or free, but generally, yeah, fine is good. Fully fine reduces the engine load on startup. Yeah, everybody happy with that one, I think. Nice and easy to start with. Which component allows a propeller or rotor to turn at its own RPM instead of the RPM of the turbine?
Gearbox.
Yeah, more specific. What sort of gearbox?
A reduction gearbox.
Yeah, reduction. Yeah, yeah, because obviously we can get about a 500 to 1, so 100, sorry, 500 to 1. That'd be nothing. 100 to 1 reduction for a rotor, maybe a 5 to 1 reduction for a tail rotor, and a turboprop could be anywhere from 5, 10, maybe even more for a turboprop. Yeah, we can't. The tip speeds of a rotor, it can't go as fast as the actual core engine. It would just be too fast. The centrifugal force would just throw the blades away. Okay, so reduction gearbox. All right, a free or powered turbine can also be described as what?
Powered by gas?
Yeah, that's it, just purely powered by gas. So yeah, a gas-only coupling to the gas generator. We tend to call a turboprop or turboshaft engine a gas generator. It's still a gas turbine, but they tend to just call it a gas generator. Same thing, same thing. Now then, the 4 requirements for all control systems are in correct order.
Accurate, positive.
Yeah, accurate.
Yeah, as well, yeah. Accurate, operation. Positive selection, yeah, reliable, and what's the last one? Yeah, E. Accurate, positive, reliable, and
something.
Definitely something.
Effective.
Effective, good man. Effective regardless of the distance between the flight deck and the engine. It doesn't matter how big the aircraft is, from your control lever to the engine. It doesn't matter if it's 1 meter or 100 meters. It's got to be effective, irrespective of the length. Good. HPSOV may have 3 positions, normally on and off, but it might have 3, which are
fuel cutoff.
Yeah.
Start position.
Yeah.
Run.
And run.
Good. And a nod as well. Good to see. A turbopropeller engine will generally have 2 control levers, which are more for a free turbine one.
Power lever.
Yeah. And what else?
And
Throttle lever.
Propeller control lever.
Yeah, propeller control lever. Yeah, sometimes known as an RPM lever, sometimes known as a condition lever. But the power lever, yeah, that's your engine side, and your RPM lever, or also known as condition lever, also known as the propeller control lever, which is all connected to your PCU, your propeller control unit, which changes the angle, the pitch of the blade. Which type of engine would normally have a single power lever?
that is fixed turbine engine.
Yeah, fixed turbine. Good. In rearward selection of the power lever in the beta range, the blade angle can be.
You mean the movement?
Yeah, just the angle. What can the angle be? There's a
Plus
range
20.
of. Yeah.
20
Yeah,
to
positive
20.
20 to negative 20.
Yeah. Plus 20 degrees to negative 20 degrees. Good. The propeller control lever is connected to the
PCU.
PCU, which is, what's that? What's a PCU?
Propeller control lever.
Yeah, nice and straightforward. Yeah, propeller control unit. Yeah, so lever control to propeller control unit. Yeah, good. Fuel system limiting can be achieved by either.
Yeah, bypass valve.
Oh, just think more basic than that. Think more basic than that.
By the throttle lever.
More basic than that. Think easy first. Two methods.
Automatic and mechanical.
Yeah.
Yeah, that's the one.
Mechanical and electrical. Yeah.
Yeah, mechanically and electrically. Yeah, just think easy first. Okay, on an LP shaft disconnect system, how many turns does the nut turn to initiate engine shutdown?
Three quarter.
3/4, good man. Is everybody else okay? Because Kanjera, he's the only one speaking, and Parmswar. Is everybody else okay with the answers? Don't sit in silence. What is the purpose of the flexible plates on a gimbal?
To
Connect to shaft.
Shaft connecting in misalignment.
Yeah, good. Yeah, just so if it was solid and there was a fraction off, that could cause a bit of problem. So it allows for slight misalignment when you join the two connections together. Okay. What's the purpose of the curvic couplings in a turboshaft engine?
Connecting with teeth. Inline
Yeah.
shaft.
Yeah, links up, connects the shaft together and that sort of thing. Yeah, it transmits the drive between the shafts using a set of mated teeth. Yeah, so they lock together. There'll be a nut at the end of the shaft that squeezes them all together, and that's what holds them for rotation. Good. What is the purpose of an anticipator unit?
Control the it control the fuel flow rate.
Yes.
Or decrease the, like it is used to overcome the drop in RPM.
Yes. Yeah, I'll give you that. It, as the name suggests, anticipates. Anticipates, it supplies more fuel as a selection by the pilot to go up. Yeah. So it gives more fuel or decreases fuel if he wants to go down as well on selection of which lever.
Cyclic or collective?
Yeah, which one? Which one is it? Cyclic or collective?
Cyclic pisli bar.
Collective.
50-50. Which one is it?
And cyclic.
No, collective. Remember, the cyclic only does one blade, the collective does them all. So when he wants to go up, he brings his collective lever up. That will change the pitch of all the blades to go up. But because they're getting lift, they start to bend. So to accommodate for that, the anticipator puts more fuel or schedules the burner, the fuel pump to give more fuel to the burner to give more centrifugal force to draw the blades out. Otherwise, we get a drop in RPM and get it called the static droop. Yeah. So anticipator anticipates the movement by the pilot on the collective lever. All right. So schedules fuel to fuel control unit before blade pitch is changed to prevent a large drop in engine RPM. Which lever changes the pitch of all the rotor blades together?
Collective.
Yeah, it's the collective. Yeah, the collective. So just think as collective collects them all. Yeah, cyclic is just one. Cyclic for single, or collective for them all. What is the name given to the slight reduction in RPM if there is no anticipator fitted when the collective is raised?
A static drop.
Static droop, good. Good. 17. Where does an APU discharge air not? What's the name of that empty space? Big tin thing. We covered it in module 17 as well. Starts with a P. Anybody? It's just like a big empty tin. Some of your motorbikes might have it above the carburetor.
Inlet plenum.
Yeah, that's the one, yeah. Plenum chamber, good. Plenum chamber. It's basically an empty space or tin. There's nothing in it. It just allows the, if you've got a plenum chamber in a carburetor, motorbike or whatever, it just takes out the pulsating air and it stores it and it doesn't need. In an APU, excess air comes in, goes in there first before it goes in. So it just sort of stays there until it's ready for use. What type of sump is fitted to the APU oil system?
Dry sump.
Dry sump, good. Yeah. The oil pressure relief valve in the APU oil system will open at what pressure? Yeah, good palm swap. Yeah, 19 psi. Good stuff. 20 at approximately 10% RPM during APU start, what event is triggered? Or what starts to happen? 10% RPM.
The fuel solenoid valve opens.
Yeah. Yeah. So fuel schedules to the combustion chamber. We've got rotation, so we've got fast enough movement of the air because remember, for any engine start, we've got rotation, fuel, ignition. So we've got 10% RPM on the APU, so it means we can schedule fuel to the combustion chamber. 21. The APU centrifugal speed switch triggers at which 3 settings? So you have 3 percentages.
It is 35, 95, and 110.
Yeah, good. 95, 110. Good. 22. An APU would automatically shut down at 100% RPM. True or false? Now again, you wouldn't get a true or false question. Yeah.
False.
Must be false, isn't it?
110.
100% happy. It's happy at 100%. So yeah, false on that one. What percentage would it shut down?
Over 110.
110, yeah, good. What happens when the APU master switch, when selected to on? When you switch that to on, what happens? So you select it to on, your master switch, what's going to initially happen? So you supply power to the APU. You've not gone for start, you've just switched it on, yeah? Because remember, it's off, on, and then run. So you switch it on. What will probably happen first? You supply power to the APU. So is there anything going to move?
Yeah, the intake.
Yeah.
Intake will open.
Yeah. And what else?
Options.
Don't all shout at once. So yeah, intake will open, so we can get air in. What else might we need for a start?
Fuel.
Fuel. So yeah, the fuel isolation valve, yeah. So intake door will open, and the fuel isolation valve will also open. If the door doesn't open, it won't allow you to start. If you're in the circuit, it will disengage at the start of the circuit. We need intake door to open, and then provide the fuel isolation valve, depending on the circuit, it might not allow the APU to start either if that doesn't open. But sometimes it can be mechanically seized where the solenoid can move, giving a false indication that it's open. Okay, but certainly the door, if the door doesn't reach a micro switch, it won't let you start the APU. And I've seen it on our aircraft where the door has opened and then closed again. All right, it has a false signal. It goes zzz, zzz, back like that, and it hasn't been reaching the micro switch very well. Okay, 24. Which two functions are carried out by the APU low oil pressure switch number 2, or LAP2 for short? Which two functions?
Yeah, opens at 55 psi and close at 45.
Good. So yeah, ensures oil pressure is 55, start up and shuts the AP down if it falls below 45 psi when running. All easy peasy. Before fitting an engine change unit, or commonly known as an ECU, to an aircraft, it must be what? Again, just think basic. Think of position. So before you fit an engine, so you get it in the cage or the cradle, you might want to do something to the engine before you fit it to the aircraft. What do we call that? Same as you get up in the morning, you also have your breakfast, whatever, and you get another name for putting your clothes on. Anybody? You'll know it when I put it up there.
Is the dressing dressed?
Yeah, that's the one. Good. Yeah, when you get dressed, we don't put clothes in the engine, but we need to put rephrasals, maybe thrust reverse components, cowlings, possibly, depending on the size of the aircraft, depending on the type of aircraft. We have to what we call dress engine or side the engine. Another name for dress an engine is, although the engine is the same on any position, the aircraft components like the doors or some fairings or rephrasals or whatever, even some pipework needs to be positioned for that position on the aircraft. Yeah, we call that getting dressed. Dressed to fit its particular location, left-hand side, right-hand side, etc. Now, thrust mountings must, short question, they must work, always a good one. They must Also what? Again, easy, we saw some answers and make it easier. Oops, what's happened there?
Thrust is forward mount.
Yeah, so what sort of load should they carry?
Side load and vertical and side load.
Yeah, close enough. Radial and axial expansion. So radial side load, I suppose, yeah, that'd be radial, and axial through the engine, forward and backwards, yeah. Set the radial and axial expansion of the engine. That's thrust mounting. 27. Fuse pins may be fitted to engine mounting installations, but what is the purpose? What's the purpose of fuse pins?
Overload or like a heavy landing, it will break.
Yeah, safely disconnect from. I say safely disconnect. If you've had a landing that bad, there's it's probably more damage to the aircraft than anything else. But I do have I'll try and get another PowerPoint and show a photograph where one has crash landed and they have disconnected. Yeah, allow quick and safe separation of the engine from the main plane in extreme load situations. It takes the strain off the wings, stops the wings ripping off the aircraft, and also being a lot worse as well. Today, why do some side-mounted engines have a thrust strut fitted? Or what's the purpose of a thrust strut?
To spread the thrust load evenly.
Yeah, between where?
Between front and rear mounting of the beams.
That's it. Yeah, it's a side-mounted engine, so you have to have a front mount, you have to have rear mount. So a thrust one is in between, so it's in the middle, so it spreads the load nice and evenly to the front and rear. One aircraft I used to work on had one of these. Very, very awkward to get into, and wire lock. It was a bit of a crazy one, but nobody liked doing it. Yeah, spread the thrust loads evenly between the front and rear thrust mountings. Good. 29. Which feature within a thrust mounting allows for radial and axial expansion? So which component in a thrust mount which allows for both those expansions? So what might you find in a mount? So it's quite a long mount, and at the ends there'll be something inside there that connects to the engine. But what is the name of those little components in there? They might rotate a little bit as well to allow for movement.
Pin?
Not pin, a type of bearing. I'll give you a clue. Type of bearing. What type of bearing could possibly take radial and axial expansion as it's fitted in a strut? It's very round, if that helps. Another name for very round bearing.
A radial bearing?
Not radial, no. If it's very round, all the way round.
Ball bearing?
Not quite a ball bearing. It's like a ball, but it's got a hole through the middle, so you can fit a pin. What's the name of that type of bearing?
Plain bearing.
No, keep going. Another name for a ball type shape, for a round type ball shape.
90% of all through the bore.
Yeah, you were thinking bleed valve, 95%. Yeah, good man. Yeah, 90% because I don't want the 100% because it'll just stick. So 95%, just enough to let it go down the pipe, and as long as it's fine, it should work okay. All right. Again, I've never, in all my career, never had to do that. Usually, you get a pipe from manufacturer, check it visually, and that'll be fine. But just be aware, if you need to carry out, there should be kits available to do that. So yeah, quite early, pass a steel ball with a diameter of at least 90% of the hose internal diameter from each end of the hose, and check the bore size. Yeah. 34. A flexible pipe should be how much longer? Oh, that should read than the distance. Hold on, I'll just change that. That's going to look a bit funny.
3%.
Yeah, 134. Just let me change that wording before I forget. 34. There we go. Yeah, flex pipe should be how much longer than the distance between the ends of the component. And you said
3%.
Yeah, 3%. That allows for a little bit expansion of the component, not the pipe, because if the pipe is the exact same length, yeah, it'll fit it fine. If the aircraft gets cold, that's okay because the component will contract, so that'll allow the pipe to move. But if the component expands and it's the exact same length, well, it's just going to stretch the pipe and possibly rupture as well. So having a little bit extra just gives it a little bit of play for expansion. Flexible pipes are pressure tested. How many times their working pressure? So let's say I give you a hydraulic pipe at 3000 psi. I want to test its full pressure, but it has to be tested a certain amount of times more than its working pressure.
1.5 times.
Flexible pipes are made from Teflon or what's the other material someone used?
And rubber.
Yeah,
synthetic rubber.
Yeah, synthetic rubber, good. Where the cold stream and hot stream gases exit together is known as the
combined nozzle.
Yeah, common nozzle assembly, or CNA. Yeah, CNA. If there is a suspect bow in a member, the bowing must not exceed what? Now, bow is just a bend, like a banana shape. Yeah, should be straight, but might be a little bit of a bend in it. So, what was the limits for that?
3% greater than the maximum distance between the thickness.
No, not 3%. Think of a fraction. Anybody else? Saroj? Just see if anybody else can speak as well. Can Jindera's doing all the work? And Pamswar as well.
Is it one? Not exceed than 1 or 600?
Yeah, 1 in 600 or
0.02 inch per foot length.
Good. Yeah, 1 in 600 or 0.02 or 20th of an inch, as we call it, per foot length. So it's not a lot. 1 in 600 or 20th of an inch. It's not a lot because if you imagine, if you've got a rod and the distance for the rod is that much, if you bend the rod well, that's like the rotors in a helicopter bend, isn't it? You're going to decrease the length of it. So that can affect fitting. So always be careful when you're fitting thrust struts, not to drop them and twist them and bend them. They can be easily damaged. Okay, 39. What is the purpose of a thrust strut fitted to a side-mounted engine? We've heard this one already, but just a bit of recap.
To bear the load.
Yeah. Between what?
Between front and rear mounted.
Yeah, spread the load evenly between the front and rear mounting. I'll change that one because I just realised that I've had that question already. Okay, and last one before tea break. Turboprop engines are normally mounted in, don't say the aircraft.
Pod mounted.
Not pod mounted.
No, then it's cowling.
Not the cowling, no.
Pylon.
No, no. What's the sort of what? I can't say the name because I'll give you the answer. There's a structure. There we go. There's a structure that the engine is fitted into, and what type of structure is it?
Tubular.
That's the one. Yeah. Who said that? If you can there. Yeah, steel tubular construction or tubular steel frames. Yes, like a cage type thing. And again, when you see one with the cowlings off it, it doesn't look like there's very much holding it in. It's quite there's one fixed one, there's one adjustable one, and one at the back sort of thing. There's not a lot actually holds an engine in. It looks when you first take one out, you go, is that it? Is that all it holds an engine in? It's when you first see that, it looks very strange. Okay, good. Right, that's 10 past. Let's go for our first tea break. We've got another 10 questions on the PowerPoint. Right. Okay, we've got another 10 questions left to just finish off on the recap of Book 3. And then if you have any questions you want to go with Book 3, let me know. And we'll go through it and then we'll start on Book 4. Okay. Right. Let's get down for another few questions. Okay, so 41. 41. In pod-mounted engines, the cowlings are normally made from what type of material?
Aluminium.
Yeah, aluminium alloy. Yeah, good. Aluminium alloy. 2. Before excuse me, my spelling. I just did that quickly last night. I want to change that. Silly Billy. Okay, it's what was that? 42. So you do things late at night and you just miss stuff. So before select, there we go. Better. So before selection, bleed air on an APU. How long should it be run at its no load speed?
2 minutes.
For bleed air, yeah. 1 minute. 1 minute for no for bleed air. Okay, there's 2 very close. There's one before you select bleed air, you let it stabilise for a minute, and then the next question that's coming up is the one you're thinking of. Okay, so it's 1 minute before you select bleed air. So basically, things switched off, let it settle down. It's already at 100% anyway, but just let it settle down a little bit. Give it a minute, and then you can select your bleed air. Okay. The next one is the one you're thinking of. Prior to shutting down the APU, how long should it be allowed to operate at no load? And this is then
2 minutes, yeah.
Yeah, so this really let it cool down. When it's up to 100%, and at least 95% anyway, because we don't select the bleed air until it's 95%. But you might have had something on, hydraulics or whatever. If you switched it off, give it a minute, then you can go for bleed air, just to let it stabilise. Always take your time, APUs. Don't rush things too much. Don't go putting hydraulics on and off very quickly or bleed air off and on very quickly. Always nice and steady. Let things settle. Oh, it's just a baby engine. Okay, it's just a little engine. So 2 minutes for that one. So 1 minute for your bleed air, 2 minutes for shutdown. All right. What type of valve is the APU bleed air valve? What type is it? Yeah.
Solenoid control pneumatically operated valve.
Fantastic, good man. Yeah. Solenoid controlled pneumatically. In fact, I've got it spelled wrong as well. Let me change that. Pneumatically operated valve. Good. Good, good, good. 45. At what temperature does the immersion thermocouple open the over temperature switch? I'll give you a clue. It's above 600. So what temperature does the immersion thermocouple open the over temperature switch? There's two temperatures we spoke about yesterday. Good, yeah, 695, yeah. Good, 695. What percentage RPM, excuse me, does the APU gen off buzz light illuminate? In other words, the generator. In other words, when you generate off, light comes on. Because when your generator's running normally, your light should go off, okay? If it fails, the light will come on to let you know it's not working. So when the light is off, so what percentage? How much? All right. Anybody?
$95.
Yeah, good. Good on 95%. Yeah, 95%. The quantity of fuel supplied to the APU burner is scheduled by the, and somebody asked the question first thing this morning.
Is
supplied by?
bypass valve or accelerator control.
That's the one. Good. Yeah, acceleration control, or commonly known as the bypass valve. That is controlled by air pressure from the compressor. As the engine is getting faster, the air pressure delivery will get higher, so it goes in the diaphragm, and that will pull the valve back up to reduce the amount of fuel flow. We don't need a lot as much, so it doesn't go too fast. Hence the acceleration control. So it is like a throttle valve, but it just bypasses some of the air and just reduces the fuel flow as we get faster, so it doesn't go too fast. 48, the low oil pressure switch, LP1, closes at what PSI?
4 PSI.
Yeah, 4 PSI, good. 49, how's the provision of cooling and ventilation of an APU carried out? So what helps keep the APU cool?
Oil.
Well, yeah, it does keep it cool, but what outside of, not inside the actual APU, but in that area of an APU?
Fan
Yeah,
driven.
yeah, we've got a fan, overheat fan as well. We can actually driven by the accessories gearbox. The last one, power for the starter motor can be obtained from battery or where else?
PMA.
PMA? Nah. That's for jet engine. Yes, it is an alternator, but that's the jet engine one. We won't get that till the engine runs. And then the APU will shut down anyway. So we've got the battery, the aircraft battery. Where else can we get power?
GPU?
Yeah, external unit, something on the ground, an external power unit, yeah. Just like normal external power supply. You'd have plugged into the aircraft anyway for starting APU and, you know, just for general power until the engine starts up as well. No point in wasting battery power if you don't need to. So yeah, aircraft batteries or from external power source. Good. And that's the end of book 3, sort of recap questions, just a few there. All right, so any questions you want to go through yourself, any part of book 3? Again, we will recap again, definitely Friday, maybe a little bit of Thursday, depending how much time we've got on Thursday afternoon, because we should be finished book 4 by probably Thursday lunchtime or just before first break, Thursday afternoon. So anything you want to go over book 3 before we move on to book 4? It's not too bad. Book 3 is a nice little book, so there's not too much in it. So hopefully that's made not too bad a sense as we're going through. Okay, but again, we will recap it. We'll do put some more questions up, and I've got 100 questions on PowerPoint for Friday that combines all the books. Okay, so a snapshot of all of them, but we'll go through the books individually and then do the big one as well. Okay. Okay, folks, if not, we shall go for book 4. Let's get book 4 up on the road. All right. There we go. The last book, the last big one. All right. So the home stretch now. So let's go through that. Usual me contents. Right. Things we're going to look at. Book 4.